Now let's talk about the simplest case of recovery where we have an explicit abort of a transaction. There's no crash involved, but there's a transaction where the user or the application requested to roll back work. What we want to do here is we want to play back the log in reverse order, undoing any updates that might have been flushed to the database disk. So to do this, we have to start at the last thing that this transaction did, and it's easy to find that. We look at the last LSN of the transaction from the transaction table, and that's going to allow us to begin bouncing backwards through the log. Okay. Before we do anything, though, we're going to write an abort log record into the log at the end of the log before we start rolling anything back. And then we can follow this chain of log records backwards from the last LSN via prev LSN records in the log to kind of bounce back through the actions of this transaction in reverse order and undo them. One detail here that's important is that before we ever undo anything, we write a log record saying we're about to undo it. Okay, so we're going to even log our undos. That's called a CLR, or a compensation log record. We're going to write one of those at the end of the log for each action that we undo. And CLRs are a type of log record we glossed over before that we're going to go through now. So, suppose that we need to undo a transaction. We're going to need to update all the pages that that transaction touched, which means we're going to need a lock on those pages. Do we have such a lock? Fortunately, we're doing strict two-phase locking. So if we did something to a page, we had to have a lock on it. And because it's strict two-phase locking, we haven't let go of any locks since we haven't committed or aborted yet. And so we definitely have a lock on any page we need to undo. And this is the connection between strict two-phase locking and ARIES, is right here. That when we're at the end of a transaction and we need to undo, we need to have locks on those pages, or tuples, or what have you, and we have those locks. Now, before we restore the old value of a page, as I said, we're going to write a CLR to the end of the log. So look at the picture at the top of the slide. We're currently undoing some particular LSN, okay? And we're writing to the end of the log a CLR for this transaction. And the CLR is going to have one extra field in it. It's called the undo next LSN. The value of the undo next LSN is the prev LSN of the record we're undoing. So again, in the picture at the top, the arrow on the left points to an LSN we're undoing. The next thing we should undo is 1, 2, 3, 4. It's the prev LSN of the current log record. And so in the CLR, we're going to write down that the thing to undo next is 1, 2, 3, 4. It's the undo next LSN of that CLR. And that means that if we crash, when we come back up, this CLR is going to tell us where to pick up where we left off. We've already taken care of the log record we're pointing to. The thing to undo next is 1, 2, 3, 4. Okay, so that's what the undo next LSN is going to be for. CLRs contain information for redo, so that if we crash and come back up, we will redo our undos. We will replay all those CLRs, undoing the things we undid before the crash. Okay, so undo is going to be durable. Undo is going to persist after the crash. If it doesn't persist at a crash, we'll redo it and make sure it did. CLRs don't have any undo information. We never undo our undos, okay? We're going to do undos for aborted transactions exactly once. Undos don't have to be idempotent. That's a term that's worth knowing if you don't. An action is idempotent if it's the same if you run it more than one times than if you run it one time. Undos don't have to have that property, actually, because we're going to undo them exactly once, I promise. And that's through the logging protocol and the undo next LSNs. We're going to redo these CLRs when we do recovery, but we're never going to undo them. And by redoing them, we will make sure they happen effectively exactly once. Okay, so there's going to be exactly once undo guaranteed for aborted transaction actions. At the end of all of our undos, when we're done bouncing through the prev LSN chain of our LSNs, we're going to write an end log record to the end of the log saying that we finished undoing this transaction. A nice idea in transactions is the idea of checkpointing. Conceptually, we want to keep our log around for a long time. Databases can last for decades, and we will have a log of all the actions on that database forever. But that has performance and implementation problems. Imagine having to recover the database by replaying all the actions over the last decade. That would be super inefficient. Instead, what we want to do is periodically checkpoint the database. It's sort of like taking a snapshot of the current state of the database on another device. Okay, so copying all the pages of the database to another device. So we have a checkpoint of where it was. And then we can just start recovery from there, is the idea. We don't have to restart recovery from the beginning of time. The problem with that scheme is that actually taking a physical checkpoint of the database could take an incredibly long time. If you've ever backed up a disk on your computer, you know it's extremely time consuming. It's just a lot of I/O to get through a small channel. And so we want to get the effect of a checkpoint without actually copying all the pages of the database. And ARIES has a very clever scheme integrated in it for checkpointing with minimal information. And the basic idea in ARIES is we already have all the data in the database on the database disk. The thing we lose at the time of crash are those in-memory tables that we had, like the transaction table and the dirty page table. So here's how we're going to do what ARIES calls a checkpoint. Okay, we're going to write the following to the log. First, we're going to write a begin checkpoint record. And it's just going to be a marker in the log, a place and time that says a checkpoint is coming. And after that begin checkpoint record, we're going to start copying the transaction table and the dirty page table into an end checkpoint record, and then we'll write that end checkpoint record to the log. In essence, this is a fuzzy checkpoint. So while we're gathering up information into that end checkpoint record, other transactions are doing their thing. So all that we know is that the data that's in this end checkpoint record is some version of the transaction table, some version of the dirty page table that comes after the begin checkpoint record and before the end checkpoint record. Okay? And then we're going to write that end checkpoint record to disk. Okay, so the checkpoint is actually two records, the begin, which is a marker in time, and then the end checkpoint record, which has the transaction table and dirty page table as of some mixture of times after the begin checkpoint record. We're going to store the LSN of the most recent checkpoint record for the database in a safe place. We'll call that place the master record. We'll put it in a physical location we can always find, let's say block 0 of the log file, so that at recovery we can find the master record. The master record will point us to the most recent checkpoint, and we can recover from there.